So I'm going to be presenting you a brief explanation about the experiment redox titration. In this experiment, we're using potassium permanganate to titrate oxalic acid. Okay? So the titrant is your potassium permanganate. The potassium permanganate is this purple, super dark purple solution that I'm showing you here. The first thing that you're supposed to do in this experiment is to prepare a dilution of this potassium permanganate. The original solution that we have has a concentration that is equal to 0.2 molar. What you're supposed to be preparing is a dilution with a final concentration equal to 0.02 molar, and you need a final volume that is equal to 100 milliliters. Since you have an initial concentration 0.2 molar, you have a final volume which is 100 milliliters, and you have a final concentration that is equal to 0.02 molar, you can use those three numbers in the dilution equation to calculate which or how much you need or what volume you need from your potassium permanganate with a concentration equal to 2.2 to prepare your new solution with a concentration equal to 0.02. I did my calculation in the amount that you need is 10 milliliters. So if you take 10 milliliters from your potassium permanganate, and then you add to those 10 milliliters 90 milliliters of distilled water, your total volume is 100, and you will have a solution that has a concentration that is close to 0.02. I'm using graduated cylinders to measure those volumes. So we're preparing a solution that is approximately 0.02. But the first thing that we're doing in this experiment is actually doing a titration to determine the exact concentration of your potassium permanganate solution. So I have here already my dilution, and this diluted solution is the one that I need to use in my burette as the titrant. So that's the first thing that we're supposed to do in this experiment, preparing the dilution for potassium permanganate. Now I have here the setup for everything that we're doing, sample preparation wise. We're using oxalic acid with a known concentration. The oxalic acid with a known concentration has a concentration equal to 0.15 molar. Is this one that I have right here. So since we know the concentration of oxalic acid here, we're preparing our samples. We can actually calculate how many moles of oxalic acid we have in each sample. And based on that number of moles, we can calculate a number of moles of potassium permanganate, and we can use that number to get our final or exact concentration of the dilution that we just prepared. So to prepare our samples, we're preparing 3 samples in exactly the same way. In each sample, we need 10 milliliters of distilled water, 4 milliliters of oxalic acid with a known concentration, and 4 milliliters of sulfuric acid with a concentration that is equal to 3 molar. So I already measured the things that I need, and I'm going to show you how just to mix everything to get your sample ready. So I am adding the 10 milliliters of water first in the Erlenmeyer flask. Sample 1, it's ready. So I have my water. I already measured my oxalic acid. I'm adding the oxalic acid in the second sample. And then finally, I'm adding the sulfuric acid. So I have everything that I need in my sample here. Sample number 3, that one I already prepared that one, and it's already heating up. We need to heat up the samples to a temperature that is between 75 and 80 degrees Celsius before we do the titration. So I have my 3 samples, and I'm heating up the third one, which is right here in the hot plate in the back. So this is the sample containing the water, the oxalic acid with a known concentration, and the sulfuric acid. It's ready, the temperature is already at 75, so I'm going to remove the thermometer. And I'm going to change my setup here a little bit. I'm going to remove my sample from the hot plate because you don't want the sample to be the temperature to be going up. It's already at the temperature that we need, so it's ready to be titrated. So I'm removing the sample here. I'm placing paper towels. As you can see, I have paper towels in the table everywhere because we don't want any permanganate to get in the table. So I have the burette, it's ready. The initial volume of the burette is at 0. I fill the burette using the dilution for your potassium permanganate. So we have the initial volume at 0, and then I'm going to start titrating the sample. Slowly. And you can set up your burette to let the permanganate go in the solution drop by drop. So as you're adding the permanganate, you can see that the color is looking purple. That's the color of your solution for permanganate. So we're going to continue adding the permanganate into your flask until you get to see the color change at the end point of your titration. You have to swirl your sample once in a while to mix everything. And you have to continue doing that until the color changes. At that point, you're going to close your burette and you're going to record how much potassium permanganate you used to complete all of your titration. Once you're done with the first sample, you have to titrate the other 2 samples. So that's what we're doing in this part. We're titrating a solution of oxalic acid with a known concentration. Now for the next part, we're preparing a sample. In a similar way, we're adding 10 milliliters of distilled water, 4 milliliters of oxalic acid, and 4 milliliters of sulfuric acid. That part is not changing. We're adding the same 3 things. The difference between our 3 samples here in this part and the 3 samples that we have to prepare for the next one is that these samples here are prepared using oxalic acid with a known concentration. For the next part, we're actually using oxalic acid, but the concentration of your solutions is unknown. So what we're determining with these samples here is the actual or exact concentration of that solution of potassium permanganate, the diluted one that we prepare. We know it has to be a number that is close to 0.02, but we actually want to know exactly what concentration we have. Now, for the next part, what we're actually doing is using a solution with a known concentration of potassium permanganate to titrate our samples of unknown concentration of oxalic acid. So we're doing the same titration, but this time what we're trying to calculate is the concentration of that unknown solution of oxalic acid. The titration is still the same. You still have in your burette the diluted permanganate, and you still have in your Erlenmeyer flask your sample containing the oxalic acid, sulfuric acid, and the water.